How can we get these slides?
We'll figure something out. So let me introduce our next speaker, which is Professor Frank Mitloehner from UC Davis, California, USA. I think many people in the room will already know Frank. He's very active scientifically, but also on social media. I will not take too much of the time here. I'll leave the floor immediately to you. So please go ahead. This is the pointer. Thank you.
Thank you very much. Good morning, everybody. What a great group of people to talk to. Thank you very much to the organizers, Professor Leroy and IDF for setting this up. We're excited to be here. The title of my talk is the 2050 Challenge, Can We Eat Our Way Out of Climate Change? And I'm not even being facetious here, I really mean it, because some people think we can. Some people think all we have to do is change what we eat and then we can halt climate change. So I'll talk about that. Now, a little call out here, if you're not on Twitter, you should be. Many of you I know from Twitter. I have been active on it for a year now and it has changed my life. To the better, because I've met many of you. So, first I just want to talk a few minutes about climate change and what drives it, and just a little climate change 101, so to say. For those of you who are not familiar with what this is all about, well, I will not go into any kind of depth here, but we see all different kinds of changes occurring throughout the world, and we do believe that climate change has a lot to do with it. Whether it's the poles, you see here the North Pole, and at the North Pole you see a shrinkage of ice caps here from the yellow area 10 years prior to this photo being taken. Today you can actually take a ship and you can surround the North Pole for the first time ever. But it's not just an issue limited to the poles, it is an issue that we see all over the world occurring. And most climate scientists will tell you that human activity has to do with increasing severity of climate change. Just really briefly here, what are we talking about? We're talking about the sun radiating down solar beams to the surface of the Earth. Normally, they'd be reflected back into space if there weren't these so-called greenhouse gases. These greenhouse gases such as CO2, methane, nitrous oxide, and others, basically almost put a blanket over our atmosphere, preventing the radiant heat from the sun from escaping. Okay? So we do need to have greenhouse gases. They make life on Earth possible. But the question now is how much is enough and how much is too much? And we believe we have too much in the atmosphere, particularly too much CO2. Most climate scientists will tell you that the main human-caused culprit of climate change is connected to the use of fossil fuel. But many people in the more anti-livestock arena will say, no, it's not fossil fuel, it's really livestock. And that's what my talk will circle around. Here you see three of the greenhouse gases that are often discussed: CO2 to the left, methane in the center, and then nitrous oxide to the right. These greenhouse gases differ in more than one way. But the one way that's most often discussed is the so-called global warming potential. Global warming potential refers to the potency of these gases to trap heat. And as you can see here, the gases differ with respect to their global warming potential, with methane being almost 30 times more potent trapping heat than CO2, nitrous oxide almost 300 times more potent. And this is where the story ends to many people, and it shouldn't, because there are other differences across these greenhouse gases in addition to the global warming potential. For example, CO2 has a lifespan of approximately 1,000 years. Anytime you've ever burned gasoline or any kind of fossil fuel with your vehicle, let's say, you have generated CO2, and that CO2 is still in the atmosphere. And it will remain there for 1,000 years. It has only one way to go, and that's up. That's CO2. Nitrous oxide is similar, also a long-lived climate pollutant. Why am I telling you that? I'm telling you that because methane, the main greenhouse gas associated with livestock, is different. Methane, while more potent on a global warming potential scale, has a lifespan of only 10 years. And then there is a chemical process in the atmosphere that's called oxidation, to be precise, hydroxyl oxidation, that takes methane out and changes it. And I will show you a few slides in a minute. So first of all, CO2, how does CO2 develop? Well, we all know that we have a lot of fossil fuel in the ground, oil, coal, and gas. It had been there for a long, long time, millions of years, and then over the last 50, 60, 70 years, we extracted a lot of this oil, coal, and gas, pretty much pure carbon, from down there. We have extracted it, and what did we do with it? We burned it. So where is that carbon now? That carbon is now in the atmosphere. And every time the sun hits those carbon molecules, they heat up, they trap the heat. That's why most climate scientists will tell you that the use of fossil fuel is the main human culprit of the Earth's warming. So this curve here is a curve to remember. So now comes the so-called methane budget. This here is a budget showing that how different methane really is from other long-lived climate pollutants, such as CO2 and nitrous oxide. On the global side, methane has both emissions associated with it, that means processes producing methane, such as fossil fuel production use, agriculture and waste, biomass burning, wetlands, and so on. And all of these processes combined globally amount to 560 teragrams. 560, just to give you a number. But on the methane side, we truly have a budget with emission sources producing that gas, and on the other side, with sinks taking it out of the atmosphere, namely hydroxy-oxidation, and then also a function of soils which serve as a sink for methane. And if you now look at the total amount of methane that's basically going to sinks, it's 550 almost teragrams. So we have 560 on the one side being produced and 550 on the other side being destroyed. And the entire discussion around methane that we hear in the media focuses on this side only and neglects to mention this side. And this is an omission that has hurt animal agriculture and waste more than anything else. Okay? It is very important to know that methane is not just produced, but it's also destroyed. Remember hydroxy-oxidation. What does that mean? That means there are chemicals in the atmosphere called radicals. And then if there's a methane molecule in the atmosphere meeting a radical, that radical will steal one of the hydrogens out of, from CH4, methane, then becomes CO2, carbon dioxide. And that takes 10 years. Takes 10 years. This is really important, maybe too technical for some of you, but it is important to get this idea. Methane is not just produced like CO2, it's also destroyed and consumed. And you will hear more about this later from my colleague, Dr. Kane from Oxford. Now I take you back to your high school years, okay? Remember photosynthesis in plants. What do plants need to grow? They need two things mainly. They need sunlight and they need atmospheric CO2, carbon dioxide. When they consume CO2 and sunlight, they produce cellulose. And cellulose is a carbohydrate we as humans or pigs or poultry cannot digest. However, ruminant animals can, and they are the focus of today's meeting. Ruminant animals can digest cellulose because of the microbes contained in their rumen, and when they do so, they have the unintended consequence of producing methane. So now, sun, CO2, needed for photosynthesis, then a bovine, for example, eats that plant. And by doing so, it upcycles non-human edible feed into highly digestible food from that animal. But as an unintended consequence, methane is belched out, or it comes from its manure. But after 10 years, that methane is degraded into CO2. And that's in the atmosphere again. So we have atmospheric carbon here, converted into plant carbon, going into a bovine, and then that carbon that was contained in here is now becoming carbon contained in methane. It's then converted back into CO2, and that carbon cycle goes around and around and around. It is a cycle. Please take that as a take-home message that the carbon that goes into a ruminant system is not a one-way street from one place into the atmosphere, but it is cyclical. And here's how that differs from fossil fuel-derived greenhouse gases, where you have carbon stored in the ground for a very long time, And that energy that's contained in that fossil fuel also stems from the sun, right? From hundreds of millions of years ago when plants took on that solar energy and then eventually fossilized. We are now taking that fossil fuel out of the ground. What do we do with it? We burn it, and once we do so, we produce CO2, put it in the atmosphere. So much so that we are overwhelming any kind of sinks that are out there, including soils and plants and so forth. This here, ladies and gentlemen, is a one-way street from down here into the atmosphere. And this here is cyclical. This cow cycle is cyclical as long as you don't add additional livestock to the herds. If you have constant livestock herds, and now comes the tagline here, if you have constant livestock herds, you're not adding additional new carbon to the atmosphere. If you're not adding new methane to the atmosphere, you're not adding new warming. Think about what I just said. This here is adding, This here is adding new warming because we're taking carbon from down here, we put it in the atmosphere. That's new carbon, that's new warming. This here is not new carbon, it's not new methane, it's not new and additional warming. That's why it is such a major mistake to compare cows to cars. Nobody should compare cows to cars because what happens to those greenhouse gases is so different that in my opinion it is just filled with flaw to compare these two. Now you will hear from one of the speakers here today, Dr. Kane, in a very eloquent way I might add, why we should not treat methane the way we treat CO2. Why it is so important to really understand the differences in the chemistry of methane compared to other greenhouse gases. And it has profound public policy consequences because now we have people out in drones saying we should change what we eat, we should become vegans, or we should go meatless Monday, or we should do X, Y, and Z based on the methane story of ruminant livestock. Not just ruminant, but mainly ruminant livestock. Because ruminants produce more methane than, let's say, pigs or poultry. Because they are ruminants. Because they can take cellulose and convert it into animal source foods. So I will be a little bit US-centric in my talk, but I also try to be international as well. But at first, I just want to give you an idea what an official agency in a country like the US says are the main culprits of greenhouse gases in an industrial country such as the US. This here is the emission inventory of the United States, and you can see here power production and use, transportation, and other industries. That's, for example, the cement industry. These are all fossil fuel consuming and producing, CO2 producing industries. They are the main culprit. In the US, in European countries, about 80%, 80, of all greenhouse gases stem from fossil fuel consuming industries. Now, the EPA used a cow, which is kind of unfortunate, to characterize or depict agriculture. But this 9% is not the US contribution of animal agriculture, this is all of agriculture. In the US, animal agriculture alone produces approximately 4% of all greenhouse gases. Those numbers are very similar in European countries. They can, however, be higher in developing countries, simply because they have less fossil fuel consuming industries there and relatively more livestock. For example, in Paraguay, you might have twice as many ruminants as you have people. As a result, the percentage of livestock contribution to their carbon footprint is higher percentage-wise. So you have to now be very careful to not use a global average number, such as 14.5%, the most recent number by the FAO in Rome, to depict emissions from individual countries. Because a global number is just that. It's a global figure depicting the totality of livestock. But that global number does not hold true for a country like this one here, or the US, or Paraguay, or Ethiopia. Don't use global numbers unless you really mean to make global statements. But that's precisely what people do. They say globally livestock produces more emissions than, than a certain sector. That's not very helpful, in my opinion. This here is the global greenhouse gases emitted by all anthropogenic sources, 49, let's say 50 gigatons. And these three wedges here are the total contribution of the United States to global greenhouse gases. So the total contribution of the United States to global greenhouse gases is 12%. As you can see here, the lion's share of the US contribution, the blue one here, that's fossil fuel use in the United States, contributing to total global greenhouse gases. And everything we eat in the United States combined, that's the small wedges here, makes up 1.1% of greenhouse gases globally. And half of that, 0.5%, is animal source foods. So if all US Americans would stop eating all animal source foods, we would produce global greenhouse gases by about 0.5%. I'm just back from Germany. Germany contributes to 2% of all greenhouse gases in the world. That's all sources of society. If they were to go meatless Monday, or if they were to go vegan as a nation, the result would be a non-measurable amount of reduction of greenhouse gases. I can assure you that. We would not be able to measure the differences between them eating an omnivore diet or a vegan diet. Yet many people in public policy and in NGO areas and so on say it would make all the difference in the world. It would not make all the difference in the world, in my opinion. I will now talk about a topic that is near and dear to my heart, and it gets those 300 undergraduate students who I teach at UC Davis to the fronts of their seats at 8 o'clock in the morning, I might add, which is not easy to do. It's the so-called 2050 challenge, and what it refers to is the following. On the x-axis of this slide, you see the years 1750 to 2050, hence the name 2050 challenge. On the z-axis, you see the total human population in the world in billions. I just turned 50 years old. When I was a little boy, we were right here at 3 billion people. Today, we are at 7.6 billion people here. And by the time I'm an old man, we'll be at 9.5 billion people in the world. Ladies and gentlemen, in my lifetime, human population on this planet will have tripled. Human population on this planet will have tripled, but we will not have 3 times more natural resources to feed these people. We'll not have 3 times more water, 3 times more land, 3 times more anything. If we're lucky, we might have similar amounts by the time we're old compared to when we were young. But this is the challenge of our lifetimes, to feed 3 times more people in our lifetimes without depleting all natural resources. What you see on this slide also are 2 colors. You see that the developed countries, the so-called developed countries, are kind of plateauing with respect to human population, whereas emerging and developing countries are still skyrocketing and going higher and higher. And you will now see that the 2050 challenge is not a challenge equally felt throughout the world. This next slide here is one of my favorites. It shows a circle over Southeast Asia that contains more people in it than the rest of the world combined. More people live inside the circle than outside the circle. Clearly one of the hotspots with respect to food security for the years to come. But it's not the only one. This is another depiction here showing human population increase over Southeast Asia, as you can see, 41%. Africa will increase by almost 50%. South America slightly by 7%, North America by 4%. Europe will continue to shrink. You clearly see here that the 2050 challenge is not one that will be felt throughout the world equally, but there are hotspots. There are hotspots. And we really have to think about how to satisfy the nutritional needs, particularly in those hotspot areas. This slide here is from a German news magazine. That's why those words are spelled here in German. So what you see here again is South and Southeast Asia. You can see China will shrink human population-wise. Bangladesh will increase quite a lot. India, a country that already has 1.3 billion people, will increase by a quarter. And then many African countries will go up in skyrocketing numbers. We're talking 100, 200% population increase in these countries. Once you reach that kind of population increase, you double population in a decade. Okay? Just to give you a feel for how significant that issue is. So the question is not, are they now just going through the roof with babies? No, well, I mean, that's part of the problem. In these countries here, an average family has between 5 and 7 kids. But it's also, and particularly, increasing life expectancies. People get older, and we all want to get older, but cumulatively it means that we have more mouths to feed in the world. And this is the 2050 challenge. This here shows one of the limitations we have, the total amount of cropland. Whether we have 3, 7, 9, or 12 billion people in the world, that's the only land we have available to feed these people. And I now show you one of my favorite tricks in the world, and that is a depiction of how challenged we are with respect to farmland available to us. Imagine this sheet of paper, regular sheet of paper, being the surface of the entire Earth. I now fold this sheet of paper, and I fold it twice until it's only a quarter its original size. What you see now, approximately postcard size, is the total amount of land. The rest is water and ice. That's all land. This here is my business card. The equivalent amount of land, the size of my business card, is all agricultural land. So this is all land in the world, this is all agricultural land in the world, to feed however many people we have. And now I fold my business card into one piece that's 2/3, and the other piece that's 1/3 its original size, and then I rip my own card into pieces. So remember, that's all agricultural land. And the bigger portion of all of this agricultural land, 2/3 of it, approximately 70%, is what we call marginal land. Marginal land is called marginal because you cannot grow crops there, by and large. Some of it you might be, but for the most part, the marginal land does not have good soil quality and or enough water to grow crops. How do we use marginal land currently? Anybody? Grazing. We use that marginal land for ruminants because here we grow cellulose that we cannot digest. But ruminant livestock can digest that marginal land cellulose, cellulitic material. And by doing so, they're upcycling something that's non-human edible into high-value animal source foods. 70% of all agricultural land is indeed used for livestock. But what the pundits don't say when they critique animal agriculture for that is that you cannot really use this land any other way. You can establish golf courses there if you want to, but you will not grow soy or something else. The remainder of my business card, 1/3 of all agricultural land, is what we call arable land. This is where you can grow all crops for humans or animals. 1/3 of my business card. Remember how resource limited we are in the world. The 2050 challenge is real, and it's pressing. And we need to think about how do we use the land we have available. I have news to those people who think we can meet that challenge without livestock. We cannot. Because we would first abandon 2/3 of all agricultural land, and secondly, guess what happens? Guess what comes out the back end of that livestock that we are dealing with? Manure, which is organic fertilizer, which is half of the nutrients that goes onto the arable land. If we were to forgo livestock, we would have to double the production of synthetic fertilizers. And many of you in the room will know what that would do to carbon emissions. So I think livestock, in particular ruminant livestock, has a critical role to play in meeting the 2050 challenge. So, turning challenges into solutions. What many people are not aware of is what I think is one of the most critical issues around our food supply chain. People think of beef, people think of other ruminant species when they think of our food supply chain and its main environmental issues. But the main environmental issue around our entire food supply chain, and that's not just in the US and in Europe, but globally, is what? Food waste. This is a depiction from the National Geographic showing a US family in front of all the waste the food they waste during the period of a year. About 40% of the food produced in the US, in Europe, and even in developing countries goes to waste. In, let's say, Africa, food goes to waste at a different part of the food supply chain. Earlier on, when crops cannot be harvested on time or shipped on time or preserved and so on, whereas in North America and Europe, food waste is mainly associated at the consumer level. This slide might be too small for people in the back, but I will lead you through it. It shows the North American food losses from production, so that's the farm, to post-harvest, processing, distribution, and then consumer losses. And what you see here are what kind of foods are wasted where. This is grains, seafood, fruits and vegetables, meat and milk. And then again, grains, seafood, fruits and vegetables, meat and milk. Grains, seafood, fruits and vegetables, meat and milk. So what do you see here? First of all, you see that in a developed country, food waste mainly occurs at the consumer level. Food plates are filled to the hilt. Nobody can eat that much food, yet we are served enormous portion sizes. Oftentimes we have sell-by dates on our food items, and people mistake those sell-by dates as expiration dates, which they are not. So people look at a gallon of milk and say, it's no longer good because the date has been reached, and they toss it away, even though by that date it should have been sold. And that's it, that's all it says. People waste a lot of food, and the number one food waste group is fruits and vegetables, 50% and more. Animal source foods are also wasted at high amounts, but it's about 10 to 20%, depending upon what food group you're looking at. This is a slide from an FAO publication from now 10 years ago, but I think it's still very timely. It shows developing regions in the world versus developed regions and the greenhouse gases associated with those with livestock in those regions. You see the years 1990 to 2020, and what you see here is that in developing regions of the world, greenhouse gases associated with livestock are going up. Why are they going up? Because people demand more. They want to eat more, their populations are growing, and as a result, the herds are growing as well, and that leads to increasing amounts of greenhouse gases. And this is what we want to stop. You can see also that in developed regions, let's say Europe or Australia or North America, greenhouse gases are plateauing because livestock herds are plateauing, and that's why those greenhouse gases are plateauing as well. What we really want to achieve is this development here. What I'm about to say here is not at all finger pointing, okay? I'm not here to tell you we are doing it right and others do it wrong. What I'm here to tell you is that there are significant differences across different regions in the world, and we can learn from each other, okay? This is not anything other than me saying that. This is an important slide here. It shows the relationship between greenhouse gases on the y-axis versus milk output on the x-axis. So here you see cows producing very little milk versus cows producing a lot. And how much greenhouse gases is associated with those production levels. And each dot here represents one country in the world. What you see here is that there are many countries in the world where dairy production is dismal, okay? Very small amounts of milk per cow produced. We call these cows idle cows. This is like you running a car in your driveway. It's turned on, but you're not driving it. Or you're driving it maybe 1 kilometer a day or something, but you let it run. It's what we call idle cows, because these cows are alive and they eat, but they produce so little product that they're way, way below their potential. And then you see here going down cows that have much higher production efficiencies and as a result, lower carbon footprints. The same can be done for water footprints and so on. There is a sweet spot of productivity for dairy, for beef, for all the other commodities. And we are pretty close in finding where that is. And what I'm not telling you is that we can get a cow from India to be, where we are in the US or so, but we can get a cow from India to be at least twice as efficient as she is today. The same is true with all the other commodities. Okay? And how can we do that? For example, by helping them install veterinary care to prevent diseases, to treat diseases, to improve the genetic material of plants and animals, to help them develop a feeding system that's worth the name. Again, this is not finger pointing, but it is just to show that there are large regional differences on ruminant meat, on dairy, non-ruminant meat, and carbon emissions in this case here. So again, no finger pointing, but just a pointing out that there must be ways where regions in the world that are high emitters get into performance levels and environmental levels that are possible, biologically possible. This here is also from the FAO showing carbon footprints across different regions in the world. And you might see here that West Asia, Northern Africa, Sub-Saharan Africa, South Asia, those very same areas where the 2050 challenge turns out or plays out the most, those are also the areas where productivity is the lowest currently. So exactly those regions where we need productivity the most are currently those where that's not happening, and where we must help them in order to achieve better results. We must, because otherwise people will pack up and leave. People will pack up and leave if they cannot feed their families at home. So what has gotten us to where we are today in some countries versus not in others? So we have learned to improve reproduction. We have learned to improve animal health, better genetics. We have learned to feed better feed. And cumulatively, those four major drivers have allowed us in certain countries to decrease number of animals to historic levels. For example, in the US, we now have numbers of animals at their lowest value ever. And that drives livestock emissions down because our herds have shrunk so much. For example, on the dairy side, we used to have 25 million dairy cows in the US, 25 million. Today, we only have 9 million dairy cows. Just as a little trivia here, does anybody know how many horses we have in the United States? Anybody? 9.5 million. We have more horses in the United States than dairy cows. So why am I saying that? I'm saying that because to give you a reference point as to how small the dairy herd is now, okay? It is at record low. By the way, horses also produce methane. From a different end though, but they do. And by the way, in addition to 9 million dairy cows and 9.5 million horses, we have 170 million dogs and cats. And they are consuming the same amount of food as 70 million people. 70 million people. Of course, we will never talk about horses, cats, and dogs, but only about livestock because, why? I don't know why, but we do. With 16 million fewer cows today, we are producing 60% more milk in the US. The herd has shrunk so much, but we are producing 60% more milk. And that means the carbon footprint of a gallon of milk, or a liter of milk, or a glass of milk, has shrunk by 2/3 over the last 70 years. Has shrunk by 2/3. The same development holds true for beef, for pork. The pork production in the US from 1965 to today has tripled. On the beef side, the same thing, okay? But I don't have the time to go into all of this. I do have an appointment at a Chinese university, and I spent quite some time there. I've been there 25 times. And China just makes my head spin, okay, in so many ways. I'm intrigued by China. They are producing 1 billion pigs per year. 1 billion, half of the world's pigs are produced in China per year. I'm now not talking African swine fever, I'm talking about developments before that happened, okay? 1 billion pigs are produced every year in China. But what I find more staggering than that is that they have a so-called pre-weaning mortality. That means the number of animals dying and never going to market of 400 million. 40%. 40% of the entire Chinese pig crop goes to a landfill every year. And that's China. China is efficient. China is developed compared to other countries in the region or, let's say, in Africa, which are much less developed. Those are numbers that give the global livestock system a black eye. And they can be avoided. I do not want to install the US system all over the world. Please do not misread me that way. But what I'm telling you is, this is unacceptable. We do not have to experience that in the 21st century, and we shouldn't. And we shouldn't. It does give global livestock a black eye, and we can stop it through international collaboration, and we should. I think it's absolutely critical. I will now spend just a few minutes on this report that has been mentioned so often, the so-called E-Lancet report, because it has rubbed me in the wrong way. On the one hand, I think it is very important that we think about the food supply chain. I really do. And it is very important that we think about what we eat. So I commend them on that level. However, there are some embedded assumptions that I want to point out. Namely, one of them is that a desirable limit of food with higher carbon footprints particularly, well, they have pointed one out, a system with a relatively lower footprint. They are pointing out that we eat too much protein and that we are unable to improve production, and that means agricultural production, particularly for animal source foods. And because of that, we must reduce demand. That's the bottom line. And I have a beef with all of these. This here is one of the central graphs of Eat Lancet. It compares the environmental performance of different diets. The business as usual diet, the eat reference diet, the pescatarian diet, vegetarian diet, vegan diet, across all these different environmental parameters. Greenhouse gases, cropland use, water use, nitrogen, phosphorus, biodiversity loss. If you now follow me here, so this here is cropland use, 11.3. It goes down to 10.5 for the vegan diet. You see that these numbers are very similar. The numbers across the diets are identical for water use, 1.9, 1.9, 1.9, 1.9, 2.0. Then comes nitrogen application. These numbers are pretty much on top of each other. Phosphorus application, numbers are pretty much on top of each other. Biodiversity loss is the worst in the vegan diet. Not the best, the worst. The higher you are in the plant-based side, the greater the biodiversity loss. The only one difference that they found was on the greenhouse gas side. But there, in my opinion, they made some very serious mistakes that I pointed out to them. So according to their own data, they don't have a leg to stand on to point out that their diet or any diet has a huge impact or advantage over any other diet. How about the notion that we eat way too much beef and red meat and so on, that it has gone up over the years so much? This slide here shows 1909, beginning of the last century, versus 2014. You can see here beef in the United States has not grown between 1909 and today. Total red meat has gone down by 3% over these 100+ years. Total meat has gone up, but why has it gone up? Because of this green area, and that's poultry. We have not increased red meat consumption in the last 100+ years in the United States. Then you hear a lot, we eat way too much protein. Everybody in the room has heard this. So in the United States today, and I apologize that this is a US unit here, but in the United States today, the average consumer consumes 5.8 ounces of meat and poultry. The dietary guidelines, so the recommendation for the US population, says we should eat 5.5 ounces. We do eat this, we should eat this. So you see those numbers are not very different. How do males compare versus females? This slide here shows different age groups on the x-axis, and then on the y-axis it shows how much people eat versus how much should they eat. The blue bars show the range of what's recommended. So for little kids here, 1 through 3 years, this range is recommended. And the red dot here, or orange dot, shows how much is actually eaten. So you can see across all age group on the male side, except for those guys here, there are 3 age groups where males eat more than they should. But in the other age groups, we don't. Okay? I might be guilty, but most others are not. On the female side, most female or all female groups consume in the United States at the low end of the recommended protein intake. These are actual data, okay? This is not me making something up. These are the official data of how much protein we consume. So where do they come up with the notion that we eat more red meat than we ever have, that we eat way too much, way beyond recommended rates? We don't. We simply don't. And this is one of my last slides here. It shows the years 1948 until pretty much to date. And it shows farm inputs, agricultural inputs. As you can see, they are holding very level, very steady, whereas total farm outputs have tripled. We have had an amazing ride over the last 50, 60, 70 years in agricultural productivity. The notion that we cannot produce more and therefore we have to control demand is wrong. It's not true. We can, we have, and we will further increase productivity, and particularly if the more developed parts of the world assist those that are less developed. We absolutely can do that. Can we eat our way out of climate change? Just a few short numbers here. Let's assume you are all omnivores here. I hope you are. But let's say if you were to be motivated to become vegan, then that impact per year would equate to 0.8 tons of greenhouse gases, 0.8 tons of CO2 equivalents. One transatlantic flight, one which I just did, per passenger, leads to 1.6 tons of CO2 equivalents. So if I fly once to Europe, then that is twice the impact of me going vegan for 1 year. If the entire United States, 320 million people, were to go vegan, we would reduce greenhouse gases in the United States by 0.3%. Is it nothing? No, it's not nothing, it's something, but I think most people would agree it's not very much. If the entire US were to go vegan, everybody, we would reduce the carbon footprint of the country by 2.6%. Still a small number, but we would not be able to satisfy the nutritional needs. We would not be able to satisfy the essential macro and micronutrients that people need to survive. So we would have to import from other places. So in my opinion, the notion that we have to change what we eat, a planetary diet largely void of animal source foods, is a flawed one. And I have a beef with that. So with that, I'll leave you with my contact information here. And if you ever choose to contact me, please do. I'll be happy to entertain any questions now or later. Thank you very much. This is the most important slide, I agree. By the way, it shows something that I find intriguing. A typical California dairy with 1,000 cows, a fence line, and on the other side, 1,000 recent new homes. And these people moved here, why? Because the land was cheap. What was the first thing they did after moving there? They sued their neighbor. They sued their neighbor. That's very typical, okay? So, questions? Any questions? I hope everybody's speechless. Oh, there's a question there.
I'm just interested to get your view on why, across policymakers, they are focusing on reducing red meat. What is it about red meat, not eating red meat, that people are choosing to switch to in the face of all that information that you've just given us?
I was hoping you wouldn't ask that question. Because this is the question that I'm battling for years now. I just do not understand it. What I do know, since I have been on Twitter, is that many of the people who, prior to the carbon footprint discussion that they are now using, the same people were talking about animal welfare, animal rights, and so on. They had an agenda for a long, long time. But they have now identified this topic, the topic of my study area, as the Achilles heel of ruminant animals. And so they have switched. Because the whole animal rights thing did not really do anything for the consumers, okay? The vast majority of consumers is okay overall with how we raise animals. Yes, there are situations where there are animal welfare concerns and so on, and they must stop, but overall people were okay with that. But the climate change discussion has caught on. Overall, for the entire society, particularly the young people. And then those groups that have used this topic, they have pretty much told the public this is the #1 issue you need to consider if you want to reduce your individual footprints. And they haven't heard much of what I just presented to you.
Hi, hello. You spoke before about mitigation measures and how Europe or either United States may cooperate with Asia or Africa. Do you think that also compensation measures, they can help? And if yes, what would you suggest?
What kind of compensation measures? You mean financial transfers?
No, I mean to cooperate with the forestry sector, to compensate. So what do you think about that? Because it's a very ongoing and actual debate also in Europe. they ask to the meat sector, you have to plant forest, you have to do that, you have to do that if you want to be sustainable. So I would like to know your point of view on that.
So I think it's a very important one. There are two sectors of society that can actually serve as sinks for greenhouse gases, for example. That's forestry and agriculture. And within agriculture, it's two areas, well, it's mainly plant agriculture because plants take on CO2 and soils do too. So if you have a rangeland, let's say you have a ranch with whatever, 1,000 cows on pasture, then the soils and the grass that grows on it will sequester carbon. We are not sure yet as to how much that is. But soils in particular are a very important sink for particularly carbon emissions, and plants are too. Currently, I don't see that anybody's giving credits to people in forestry and or agriculture, but in my opinion they should, because they're the only two sectors that I can see that can actually reduce greenhouse gases. So this is a very complicated topic, and I don't think our understanding has yet grown enough to really quantify under what condition you sequester how much. But the fact is we do.
Yes, hello, my name is Kim Viggo Weiby. I'm coming from Tina in Norway. Thank you for an excellent presentation.
Welcome.
My question is, when you increase productivity on the yield of dairy cows from maybe 2,000-3,000 to 7,000, 8,000, 9,000, what happens to the use of marginal land, as you talked about? Is that a conflict between the use of marginal land and increasing productivity?
I don't see that there's a conflict because the marginal land will be used for grazing, okay? You don't do anything with it. It's not that once the animal becomes more productive, you now abandon the marginal land. The marginal land largely stays in grazing. But if an individual animal now produces more, let's say twice as much or so, then that will increase the bottom line of the producer, and overall it could lead to a situation where a country says, you know what, we now have enough milk, we no longer need the same number of cows that we used to 10 years ago. So for example, what you saw in the US, going from 25 million to now 9 million dairy cows, and increasing production by 60% is a direct effect of increasing efficiencies. And that is true across livestock systems. When I say let's improve efficiencies, I don't mean let's all go into concentrated facilities, indoor barns and so on, but you can increase efficiencies in whatever system you are. You can be a rangeland producer and double your yield, double your efficiency by using, let's say, supplemental feed or by improving the grass that you have and so on. It is possible throughout the world, and we now have to unleash that potential we have. But for that, we need to get that monkey off our back that says, let's stop eating red meat. There is no reason that I can see that would justify that. And it is this industry that has to speak up. It is all of you who have to speak up. It's not just a few, it's all of you who have to speak up. What I just learned from Professor Menke here just a few minutes ago was totally new to me. We have to equip ourselves with that type of information. And then we do have to become active on social media and other platforms and talk to people. We are a small sector. If we don't talk to people, there's another question over there. Oh.
Good morning, Dr. Mitloehner. I'm Shin Huang from the International Meat Secretariat. And you and I have known each other for many years. We worked together on projects concerning sustainable livestock development, which is the most important challenge of our lifetime, I think, and certainly the many contributions, the many positive contributions that livestock systems can make. That is what is going to make the difference. So, congratulations on your presentation. I just have a question that is maybe a little bit off topic, but not too much. And that is, today we're focusing on ruminants, and you talked about the upscaling impact that ruminants have on cellulose that we can't digest. Some of our ruminant production systems, we're also feeding them some cereals, and our critics are saying that these are cereals that can also be given to humans, and that's not really entirely true because there's also that upscaling effect. And my question is, what do you think of the upscaling benefits for monogastrics, those that are eating more cereals than ruminants, for example? Because we're all in this boat together, and you know, it's not just that we're not going to meet our sustainable development goals and our nutritional needs only with ruminants, I don't think, but I wanted to have your opinion on that.
Yeah, I totally agree. So excellent question. So because of the focus here being the role of ruminants in sustainable diets, I focused on that. And of course, what makes ruminants so special is that they upcycle, not just recycle, I'm using that term deliberately, upcycle from non-human edible feed into highly digestible and bioavailable food for our consumption. That's what makes ruminant animals so special. Monogastric animals such as pigs or poultry are also very special because while they oftentimes eat a large portion of human edible feed, soy for example, or other grains, they are very efficient in converting that. So the amount of human edible feed they need to consume to produce a unit of animal source food is very positive. I mean, they're highly efficient, okay? A broiler today is finished in 40 days. 40 days. A pig is finished in 170 days. So these efficiencies that I'm talking about, of course, apply across the livestock sector, okay? And my comments were more based on ruminants, and monogastrics are very different. They are very different, but they are just extremely efficient, and so we just have to see that. You know, they might be more in competition with respect to human edible feed, but they are so efficient that it doesn't take them very much to put that into product. So, and I want to encourage you to pay special attention when my FAO colleague here talks to you today, Anne Monet, because she and her colleagues have published some very important work along those lines of what those efficiency gains are, how much human edible feed we feed to livestock. I believe the number is 85% or so, non-human edible feed going into livestock, when the population thinks that's all we do, feeding them stuff that we could eat directly instead. And that is not the case. That is not the case. So there's a question here in the front. Excuse me, there's a question right here.
Alex Doring, European feed industry. Just building on the question raised by Frank, on this food versus feed or even fuel debate, which has been so long, I think it's one of the less communicated facts. You mentioned the excellent work of FAO, that as feed industry, we are converting not just the unedible stuff, but also the co-products of food and biofuel processing. So as I'm a German, I'll crack a joke. We love vegetarians as feed industry. Why? Because they produce such a huge amounts of co-products, which we can convert into nutritional feeds, but nobody's telling them. So, I mean, just in the European context, I think we estimate total volumes of co-products converted into feed 80 million tons. That would go to waste if there wasn't an animal population taking care of that. So it's how do we rebuild that storyline in a different way, in a more systematic approach. As you said, we're still missing facts on the nutritional side. We learned this morning, we learned a lot about climate change aspects, but when it comes to societal impacts, and climate change is a key driver, what is your vision? How do we build our case towards, say, carbon neutral or GHG neutral livestock economy to meet the global challenge that you put it on in front of us?
So, well, I live and work in California. California is an agricultural powerhouse. We produce 50% of the nation's fruits, vegetables, 90% of the nuts, and so on. And I always wonder, why do we have that many cows there in that Central Valley? We have 20% of all US cows in that valley. The reason why we have the cows there is because we have all of these co-products and byproducts from 400 specialty crops. Those ruminants eat all of these cotton seeds and almond hulls and stuff that you normally have no place for. They are, I just talked earlier about upcycling with grazing animals. They are also recycling, of course, all these different byproducts and co-products from all different kinds of sectors. I mean, without these ruminant animals, we would have to dump all that stuff on landfills, okay? And it is extremely important. Ruminant livestock in particular play a very important role in recycling nutrient streams, leading to a lowering of overall emissions from many different sectors. That, coupled with sequestration potential of soils and plants, is a very significant contributor to getting us to be more carbon neutral. And I hope that you remember that part of my talk. What's really relevant is also the fact that unless you increase livestock herds, you will not add additional carbon to the atmosphere. And that means unless you increase livestock, you're not adding additional methane. If you don't add additional methane, you're not adding additional warming. So if we do what we have been doing throughout the world, and if we manage to keep our livestock herds globally also at bay and don't increase them, then we have a very good chance of playing a very important role in the global carbon game. Okay? Livestock plays a very important role in it. Plus, we are just producing yummy food on the side. So with that, thank you very much for having me.
Thank you very much, Prof. So with this last talk, we're running a bit behind schedule, but I suggest we have a small coffee break anyhow to resource, and we can come back at 11:40. Is that okay? It's not a lot of time, so be quick, just refresh yourself, and then we'll start on time, right? 11:40.